Hey guys, I wanted to go through the steps for how to do linear regression on your calculator. So I just cleared the memory, so this calculator is all clear, and I found a problem that shows the average and the maximum longevity of various animals in captivity. So like for this particular animal, its average lifespan is 12 years, and the maximum that's ever held in captivity is 47 years. So what it's basically seeing um, is it if they're average, what I would expect is if the average is higher, then the maximum would also be higher. We're going to do that. We're going to find the correlation coefficient, use it to predict some different things, and so hopefully that you can understand more about how to do this problem as you see it work. So I'm going to go to the calculator. I've got to enter this data. So on the calculator, to do that, I push stat and then enter. And that takes me to my list. And then I'm going to type these numbers into my L1 and my L2. The X's, the average is going to go in L1, the max is going to go in L2. So I'm going to start with 12, 25, and 15. All right, I'm going to pause the video for just a second and fill in the rest of L1 and go over here and fill in the rest of L2. I'll go to the screen so you can see what I'm going to enter. Okay, I'm back and I've got all the information from that chart in the calculator. So these are my average lifespans in captivity, and these are the maximum for those particular animals. So we're going to need to I want to find the equation of the best fit line. I want to look at the data in a scatter plot, determine if there's a good correlation, find the correlation coefficient, and then we'll use it to predict. Maybe we'll find something in here in the middle and predict, well, if something has like an average of uh, 10 years in 10-year lifespan, what would be the maximum we would expect? So in order to get a correlation coefficient, I have to turn the diagnostics on in the calculator. So to do that, and you only have to do it one time. If you clear your memory, you'd have to do it again. But sorry, my phone rang, so I had to pause it for a second. So we've got to turn the diagnostic on so that we can see the correlation coefficient. Let me show you, for example, what would happen if I did it right now. I could do stat and arrow over to calculate and find the linear regression line. And right now the X list is in L1, the Y list is in L2. I'm not going to tell it where to store regression equation right now. I will when I do it for real, but just go ahead and calculate it. If I tell it to calculate, it does all of the math, but it gives me the slope and it gives me the y-intercept. And you'll see in a minute, it's going to be the exact same slope and the exact same y-intercept. My problem is that for a lot of the problems that you're going to do on your homework, you need R, which is your correlation coefficient. So in order to find R, you've got to turn the diagnostics on. So go to second zero, that's the catalog of the calculator, and scroll down to the D's and find diagnostic on. And you have to go in alphabetical order. I wish I knew a better way to get there, but I don't. All right, diagnostic on, push enter. That pastes it to your home screen, and then push enter one more time and it'll say done. So now I can actually calculate the linear regression line, and it'll give me the correlation coefficient. So go to stat, go over to calc, and go down to 4. This time I'm going to go ahead and tell it to store that regression equation. The X list is in L1, the Y list is in L2, and I want it to store my regression equation in Y1 so that I don't have to retype it. So to get Y1, you push this vars key right here, arrow over to Y vars, and choose function and Y1. So it's going to find the regression equation and store it in Y1, and I'm going to tell it to calculate. And now, exact same regression equation comes up, 1.22x plus 22.4, and the R value is 0.88, which is pretty strong, a pretty strong positive correlation, and we'll look at how that looks on a graph here in a minute. Okay, so let's talk about what these two mean in the context of the problem, where we're talking about average lifespan and the maximum lifespan. So for this particular problem, I would expect the the starting at maximum lifespan to be 22, and then for every year of average lifespan we go up, that we would add 1.2 years onto the maximum. Kind of not the best in explaining for this one, but a lot of times For every year you add, it'll add so much in dollars. It just depends on the problem that you're looking at. All right, so if we want to look, what is this going to look like on a graph? Well, if I hit graph right now, I don't see anything. And the problem is because the window of my graph, if I hit the window key, is going from negative 10 to 10. And my values over here, if you look at them, they're not going from negative 10 to 10. So what I've got to do is I've got to set up the window to match my values. And the easiest way to do that is to use the stat feature of your calculator. And I even forgot, it's not going to show up because I don't even have the scatter plot turned on. The y equals line would show up now, but it's not even showing up because it's above my window. So there's the y equals line. It's already typed in there for me. Now I need the scatter plot to show up. So I'm going to go to, this is stat plot right here. So second y equals, that takes me to the stat plot, and I need to turn the scatter plot on. Right now it's off. So turn it on, enter, and then my X list is an L1, my Y list is an L2. It really doesn't matter which mark you choose or what color you choose. Okay, so now it would graph if my window was correct. You can either set the window the way that you want it to be, or if you push zoom and then 9, your calculator will set the window for you to fit your data. So here's my points, and you can see they're not exactly on the line, but they're pretty close to this trend line. So it does look like the higher the average is on the x-axis, the higher the average lifespan, the higher the maximum lifespan is. So what if I wanted to use this? You know, I've got for 12 and 25 and 15 and 8 and 35, 40, 41, 20. What if I want to predict, what if the average was 10 years? What would I expect the maximum to be? What I can do is I could come over here and go to my table, and I could scroll down to 10, and if I look in here, go to this large screen, if you look at 10, it's 34.662 for the maximum. I would expect the maximum to be around 35 years if the average was 10. What if I wanted to know if the average was 50 years? What would the maximum be? Well, I don't want to take all day to scroll down to 50. I could, but a shorter way to do that is to change the way this table's working. So right above window it says table settings. So if you'll go there, right now my table's starting at 0. This symbol is delta, so delta table is 1, so that means it's changing by 1. It's going 0, 1, 2, 3, 4, 5. And my independent, which is my x values, are automatic, and so are my y's. What I'm going to do is I'm going to change my independent variables from auto to ask. That way, if I go back to my table now, it's empty. So I can type in what I want to know. Okay, if the average is 10, what would I get? 34.662. What if the average was 50? Then I would expect the maximum to be around 83 and a half years. Or if the average was 100, a crazy number, but I would expect the maximum to be 144.6 years. So instead of having to scroll up and down, I can find it that way to predict. So I hope that helps you a little bit on finding your correlation coefficient and your linear regression line and being able to use that for predictions. And if you have any questions, just let me know.